All right, so we're going to start systems of equations today. Systems of equations is going to, you're going to have multiple different strategies to solve a system of equations. The first strategy that we're going to give you today is solving by graphing. That's why you got the graph paper. Okay? The second way is substitution. Third way is elimination. And then the fourth way is going to be matrices. I'm going to teach you all about matrices in this unit also. Okay? All right? So if I am going to, so we're going to stick with linear systems of equations for now. In the fourth quarter, we'll get into quadratic systems of equations and solving those using the same method that we are playing right now. But we've got to learn conics before we can do that. Okay? So if we're talking linear systems of equations, that means we're going to graph multiple lines on the same coordinate system, which means that we are going to be looking for certain points of it. Okay? So let's talk a little bit about 3 different ways to graph a line. Okay? What are 3 different ways that you know of right this very second on how to graph a line? Oh, I'll say 3 different ways to graph a line. You've done it thousands upon thousands of times.
Yeah,
Yeah, this one is y equals mx plus b. Yes, you could graph this one by solving the equation for y. So first off, you would solve for y. Then you would plot the y-intercept. And then you would use the slope to plot more points. Okay? Probably your go-to method. That is probably your go-to jam. Okay? It's mine. That's the way I graph it. Get it y equals mx plus b, plot my b, do my slope, all that fun stuff. But sometimes, yes, sometimes it doesn't give us a nice b. So then you gotta come up with a different method. T-chart. Yep, exactly. You can always graph using a T-chart. T-chart. Love it. This third method, I don't know. No, we actually did talk about it first semester. Yeah, we did. So you have had experience with it. Probably don't remember it because it's the one that we probably use the least. Anybody know what it is? Nope. Nope, those are all different forms of a line, not a way to graph a line. But I like where you're going. It's the intercept method. Okay? So you plug in 0 for x, you get basically the y-intercept. And you plug in 0 for x, then you plug in 0 for y, and you find the x-intercept. And you only need really 2 points to make a line, and so then you connect those 2 points above. Okay? All right? Love it. Now, one big crucial thing here at the end. When we draw our line, what should you for sure now use? When you're going to go draw your line, you got to use something straight. You got to use a straight edge. You got to use a ruler. Okay? We talked about this first semester. We talked about you got a license, you've got the edge of a binder, you've got a ruler, you've got some of your phones, you got what? You got your ID. Okay, you got all these different straight things in your possession right now on you. You can bend your paper over to make it fit your line. You know what I mean? You could use a secondary sheet of paper. You got lots of stuff that you can use. You gotta use something straight here because of this next slide. This next slide says that when we're going to put 2 lines on the same plane, same coordinate system, okay, there's 3 possible outcomes. Okay? The first possible outcome, or the first potential outcome, is we can get exactly one solution. Oh, my dot didn't line up with my dot. What the heck? That just is not right. Okay? You want to find that intersection point. Okay? So being accurate with your lines is going to make your accuracy of your answer so much more. So drawing straight lines allows you then to get correct answers. Okay? Drawing hodgepodge lines means who knows what kind of answers you're going to get. Okay? So that using that is huge. Okay? Right? So if we are going to get exactly one solution, we are looking for this intersection point as the answer, and any 2 lines that have different slopes will intersect at some point in space. Okay? So if you have 2 different slopes, you are going to get a solution. Okay? That's one of the possible outcomes. What's another possible outcome? They never intersect. What do we call that? We call that parallel lines. Okay? So that is the no solutions case. They never intersect. What is the one characteristic of parallel lines that are the same? Their slopes are the same. Yep. So if your 2 lines have the same slope, your answer, your solution, will be no solution. That's 2 of the 3 potential answers. What's the third? Meets at one point? Never meets. Can a straight line meet at 2 points? No, can't meet at 2 points. But what? Always? Infinite solutions is what we're going to call that. Yep, we're going to call that infinite solutions. Okay? And that's when you graph the line and they are on top. They're the same lines. So those would have the same M and the same V. So if we meet at a point, the coordinates, or if the two lines intersect, the coordinates of that intersection point is your solution. If you have parallel lines, your solution is no solution. If you have the same line, your solution is infinite. Okay? Those are your three possible answers going forward here. And that's pretty much for the whole unit. Those are going to be your three possible answers. A point, no solution. Okay? Ready to try some? Do this. Here we go. So now we are on that graph paper. If you want, you should also have out something straight so that you can draw your lines with. IDs, rulers. I might have some up here. One never knows what I can find in a drawer full of drawers. Oh, I got 3. Huh? So you are going to want to graph both of your lines on the same coordinate system. Okay? So we're going to handle this in 2 different ways. So first off, we're going to take the blue line, we're going to graph it. Then what we're going to do is we're going to graph the green line, and then we're going to look for if they intersect. Okay? All right? So let's do this. How do we want to graph the blue line? Method 1 was y equals mx plus b. Method 2 was t-chart. Method 3 was intercepts. You're saying y equals mx plus b, Ray? You're getting a lot of head nods from behind you. Okay? All right? So if I'm going to solve this one for y equals mx plus b, that means I'm going to first off subtract me some 3x's on both sides. If I do that, then I get negative 4y equals negative 3x plus 8. Concur? Then I have to divide all by negative 4. That's going to give me y equals positive 3/4 x minus 2. Would you concur with that? Okay? So that tells me then that my y-intercept is negative 2. So from the origin, I'm going to go down 2, and I'm going to put it out. In my case, it's going to be 2. Then it tells me that from that dot, my slope is, what was the 3 words that are best used to describe slope? Rise over run. So that means I'm going to rise 3, bless you, rise 3 and run positive 4. So I'm going to go up 3 and right 4. Up 3, right 4. If I didn't want to go up and right, what are my other 2 choices? Down and left. So I could go down 3 and left 4. Down 3 and left 4. Okay. So I've got a good spread, especially on this first line. Remember back first semester when Mr. Roth and I were telling you you got to draw your lines all the way across your graph? That was specifically for today. Okay, we want to draw our lines all the way across the graph because we don't know where that intersection point is going to happen. Okay? So then we can draw in our line now. I'm going to make mine blue. I'm going to make mine solid. I'm going to all the way across. Now we're going to go to the green line. Which way do you want to do the green line? Y equals mx plus b, t-chart, or intercepts? Y equals mx plus b. Hey, I get it. Your go-to jam. Let's do it, man. Subtract 3x, subtract 3x. That gives me 4y equals negative 3x plus 16. Divide everything by 4. That gives me y equals negative 3/4 x plus 4. Do I know right now if I'm going to have no solution, infinite solution, or an actual solution? Why am I going to have a solution? So the slopes are different. Yep. If the slopes are different, you're going to get a solution. Okay? So that tells me that I'm going to go up 4, 1, and 2, and 3, and 4. The slope of negative 3/4 says that I'm going to go down 3 and right 4, down 3, 1, 2, 3, 4, or I could go up 3 and left 4. There we go. Then we got to still draw our line, even though we can clearly see that where it intersected, we're still going to draw on our line because that's still part of our answer, is the actual graph of this. So even though by plotting our points we saw where it did intersect, we still need to do that. Okay? So it clearly intersects right there, and that intersection point is at the point 4, 1. You concur with 4, 1. Now, if there was only a way that we could very quickly check to make sure that 4, 1 is truly the answer, we can plug it back in. We're going to plug in 4 for x, 1 for y. 3 times 4 is 12. 4 times 1 is 4. 12 minus 4 is 8. Checks in the blue. 3 times 4 is 12. 4 times 1 is 4. 12 plus 4 is 16. It checks in the green, so that is our solution. Man, I love this stuff. All right, let's do another one. Ooh, sometimes the math gods smile upon us and say, "Whoa!" Here's one already put in white. Sometimes. Plus 2 means I'm right here. Minus 3, so that's really 3 over 1, so that's down 1, 2, and 3, right 1. 1, 2, and 3, right 1. 2, and 3, right 1. 1, 2, and 3, right 1. Or I could go up 1, 2, and 3, left 1, 2, and 3, left 1, 2, and I'm off the graph. Okay, how do you want to solve the other one? Or how do you want to graph it? Y equals mx plus b. Okay. If we y equals mx plus b this one, I'm going to subtract 6x. I'm going to subtract 6x. It's going to give me 2y equals negative 6x plus 4. Then I'm going to divide by 2, and divide by 2, making sure you do all of those divided by 2s, not just one. What happens? Same line, so an infinite solution. Okay? Now, I will tell you that if this were a test, quiz, formative, homework, okay, both of these are the solution are the answer, what you need to produce. So even though by doing your math up here, you see that those are exactly the same, you still have to give me the graph. If it says solve this by graphing, you still have to graph it, even if you already know right from the start that it's infinite solutions or no solutions. Okay? With me? Love it. You now try that one. So what I did on this one is I plotted the points for the lines. Okay? I have seen in the past people give me that as a graph. Okay? That's not graphing lines. That's plotting points is what that is. Okay? You still need to, even if you know after you get done plotting them that those lines are parallel, because they are, okay? Even after that, you still have to come back and you still have to connect those dots. Okay? And then, at the very end, then you give me no solution. Okay? With me? Love it. Go for it. Yeah, right. So plus 3 is 1, 2, 3. Slope 4 is 1, 2, 3, 4 on. Alright, so there's that one. That's my blue line. And then y equals mx plus b, I'm guessing. So subtract 10x. Gives me negative 5y equals negative 10x minus 15. Divide everything by negative 5. That gives me y equals positive 2x plus 3. They intersect right there, which is the point 0, 3. If I plug in 0 into the blue, I get 4 times 0 is 0, plus 3 is 3. If I plug in into the green, 10 times 0 is 0. 5 times 3 is 15. 0 minus 15 is negative 15. Negative 15 equals negative 15, just as 3 was equal to 3. There we go. On the homework that I handed out to you, we have 4 total problems, 2 from today. So if you're looking at those, I think that the 2 from today are numbers 2 and 3. You can do. I would wait on 1 and 4 until after tomorrow. You can try them if you want, but I hate for you to have to do it.